Good morning, students. My name is K. Sonar. I am completed MSc B.Ed. Now I will handle to Science 10th class, Lesson 1, Laws of Motion. First, what is motion? A moving object is called motion. There are different types of motions: linear motions, circulatory motions, vibratory motions, oscillatory motions. Especially in this lesson, we will see the Newton's laws of motions. Then force. Force is nothing but push or pull of the object. That is called force. First, we know that mechanics. Mechanics means nothing but effect of force on the bodies. That is mechanics. Mechanics classify two types: statics, dynamics. Static means a body will be rest. Dynamics means a moving body is called dynamics. Next, kinematics. Kinematics, it means a body without cause of the motions. Kinetic means a body with cause of motions. Next, Aristotle. There are two types of motions, especially in natural motion. It force independent. Unnatural motions or violent motions, that is force dependent. Next, we will see inertia. Inertia is nothing but the inherent property of a body to resist any change of in state of rest or the state of uniform motion unless its influence upon by an external unbalanced force is known as inertia. Inertia is nothing but example a table, when we applied some external force drag, otherwise it will not move. So that is the examples. Next, types of inertia: inertia of rest, inertia of motion, inertia of directions. Next, examples of inertia: an athlete runs some distance before jumping because this will help him jump longer and higher. Yeah, you will see there's some especially in running competition, the athlete reach the point, again they will continue their running. It happened to the inertia of motions. Next, inertia of directions. Inertia of direction is nothing but when we travel on a bus, the bus will be turned left, means our body will be forward to right directions. This is called inertia of directions. Then inertia of rest means when shake the branches of the tree, some leaves and fruits are detached to fall down. So this is called inertia of rest. Okay, next topic, linear momentum. Momentum is nothing but it's denoted by P. P is called momentum. P equal to m into V. M means mass, V means velocity. Its SI unit is kg ms minus 1. Newton first law. Newton first law is nothing but a object said to be rest or motion when we applied some external unbalanced force, otherwise it should not change the state. That is a Newton first law of motions. Next, types of force: like parallel force, unlike parallel force. See the diagram, you easily understand like parallel force. When we force act on the same directions, that is like parallel force. When see a tug of war, that is the examples of unlike parallel force. Next, we will move on to moment of force. Moment of force or moment of couple is equal nothing but torque is equal to force into distance. Torque or moment of couple, F means force and D means perpendicular distance. The unit of moment of couple or torque is Nm. Couple is nothing but two equal and opposite charges separated by a very small constitute distance, that is called couple. The examples of couples are given: turning a tap, winding or unwinding a screw, and a spinning top. These are all examples of couple. Applications of torque, especially gears, seesaw, and steering wheel. These are all examples of applications of torque. Next, principle of moments. Principle of moments is nothing but it state moment in clockwise direction equivalent to moment in anti-clockwise directions. F1 d1 equal to F2 d2. Next, we will discuss Newton's second law of motion. The force is directly proportional to the rate of change of linear momentum. That is called Newton's second law of motion. Finally, we got F equal to ma. F means force, m means mass, a means acceleration. The SI unit of force is Newton. Next, we will see impulse. What is impulse? Impulse is nothing but force into time. That is the impulse. So when we play a cricket, we will catch the balls lower our hands. Why? Because do it lesser impulse we will create. That's the reasons. These are all examples of impulse. Next, we will discuss Newton's third law of motions. Every action there is an equal and opposite reactions. It is called Newton's third law. So examples, when we throw a ball on the wall, it comes opposite directions. This is the Newton third law of examples. Next, we will see principle of conservation of linear momentum. Consider two bodies A and B, and respectively their masses m1, m2, and initial velocity u1, u2, and final velocity v1, v2. See a first diagram, that is before collision. Second diagram indicates during collision. Third diagram indicates after collision. Before collision, we get initial velocity u1, u2, and after collision, we get final velocity v1, v2. Next, force on a body due to A, Fe equal to m2 v2 minus u2 by t. Force on a body A due to B, Fb equal to m1 v1 minus u1 by t. So these two equation, how we remember? A means 1, B means 2. Suppose A comes means that side fully 2. A means 1, that side fully 2. B comes means B means 2, that side fully once. Okay, according to Newton's third law of motion, action force equal to reaction force. Therefore, Fb equal to minus Fa. Enter the two equations. m1 v1 minus u1 by t equal to minus m2 v2 minus u2 by t. What is here same? T is same, so cancel it both side. Then multiple m1 inside this side, m2 multiple inside the equations. We get m1 v1 minus m1 u1 equal to minus m2 v2 plus m2 u2. So v1 v2 one side and u1 u2 another side. Finally we got the answer is m1 v1 plus m2 v2 equal to m2 u2 plus m1 u1. In the absence of external force, the algebraic sum of the momentum after collision is numerically equal to the sum of the momentum of before collisions. Next topic, rocket propulsion. We know rocket propulsion is based on according to Newton's third law of motions. Next we will move on to gravitation, Newton's universal law of gravitations. First statement, the force is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. Therefore, we get F directly proportional m1, m2, and F directly proportional 1 by r square. Next, when we combine these two equations, F directly proportional m1 into m2 divided by r square, directly proportional cancel means we add one constant. Therefore, F equal to g m1 m2 by r square. G is a universal gravitational constant. Its value is 6.674 in 10 power minus 11 nm squared kg minus 2. The next topic, acceleration due to gravity. The acceleration due to gravity of the earth, it's represent g. Its unit is ms minus 2. Therefore, its value is 9.8 ms minus 2. It's a familiar value. Next, relation between g and g. Small g, it's represent gravitational energy, and capital G, it represents gravitational constant. Consider this is a earth. Capital M represent the mass of the earth, and R is a radius of the earth. And consider object. object mass m and it exhibits some force F. Therefore we know Newton's second law of motions F equal to ma, mass into accelerations. Then accelerations due to gravity, we write here a equal to g. Therefore F equal to mg. We know F equal to mg equal to, already we know that Newton's universal law of gravitation, g m1 m2 by r square, that formula. Then F is mg. So what we will cancel here, both sides are small m cancels, small m cancel, we get g equal to gm by r square. This is a gravitational value. Then mass of the earth, suppose we want mass of the earth, means here g equal to gm by r square. Suppose we want mass of the earth m equal to, how will you write, g r squared by m, sorry, g r squared by g. Yeah, small g is a gravity value, r is a radius of the earth, capital G is a gravitational constant. When we apply this value, we get mass of the earth. Mass of the earth value is 5.972 in 10 power 24 kg. Next topic, variations of acceleration due to gravity. We know the equations, g is inversely proportional to radius of the earth. So when g increase means radius of the earth will be low. So it is inversely proportional. When g less means radius of the earth will be increase. So that reason only polar region they have maximum gravity, and equatorial region they have minimum gravity values. In center of the earth the value of g is 0. Next, mass and weight. Mass is the fundamental quantity of matter contained in a body. Its SI unit is kilogram. Weight of the body is defined as the gravitational force exerted on a body due to the gravity. So weight equal to gravitational force, mass into acceleration due to gravity. We know g value 9.8 ms minus 2. Next, apparent weight. Apparent weight is nothing but the reactions force exerted by the lift surface or taken as the apparent weight and actually upwards. Next, weightlessness. See the weightlessness. When the person in a lift moves downward with an acceleration equal to the acceleration due to gravity, when a equal to g, here acceleration due to gravity, this motion is called free fall. Here the apparent weight r equal to m g minus a. Here g minus a, acceleration due to gravity, that reason it comes g. Therefore we get r equal to 0. Then these conditions or state refers to the state of weightlessness. Next topic, weightlessness of the astronauts. Astronauts are not floating but falling freely around the earth due to their huge orbital velocity. Since the space station and astronauts have equal accelerations, space station astronauts are equal accelerations, then r equal to 0, hence the both astronaut and the space station are in the state of weightlessness. Next, applications of Newton's law of gravitations. So dimensions of the heavenly body can be measured using the gravitational law. So these are all applications of Newton's law. We measure the heavenly bodies, means a large bodies. Next, it helps to discovering the new stars and planets. It helps to predict the path of the astronomical bodies. Okay, thank you students. This lesson completed.